Hello, my name is John Metzcar. Uh, I'm here today presenting the setup guide for macOS for PhysiCell. It's produced by myself and Randy Heiland. It's part of the PhysiCell project. We're doing an updated install guide in particular, to reflect changes that may have been made, and in particular to support the upcoming hackathon, 2022 PhysiCell hackathon. Materials for the hackathon and general training and use purposes can be found at this link on GitHub as well, or by otherwise following the link that this QR code leads to. All right, well, so let's get started. I guess I'll just say that I am a PhysiCell user. I'm a graduate student in the Math Cancer Lab and Intelligent Systems Engineering at IU. I'm also an informatics graduate student. So today we're going to go over ultimately we're going to go over all the requirements for that hackathon, plus a couple extra things. And it's divided into sections. So we have a minimum setup. That is the setup that's the minimum setup required in order to compile PhysiCell and execute a program in PhysiCell. So that includes getting the compiler as well as the source code for PhysiCell. And then there's a typical modeler setup that includes adding Python 3, which enables a lot of additional capabilities, including the use of intracellular models. And so this testing and building this intracellular model is in essence a test of your Python 3 installation. ImageMagick, which is used to use visualizations to give you feedback on their models. And then the PhysiCell model builder, which is a graphical user interface or GUI for working with PhysiCell models. And so that's if you will, a standard modeler setup. And then for the hackathon, we're going to be using a program called Capacity to edit systems biology markup language. And it has additional features as well. And then oftentimes folks use some kind of editor, text editor for C++ and for Python. So we'll just touch that briefly. And then version control with Git and GitHub will be touched very briefly as well. And then there's a couple notes on this install guide and presentation itself. We've tried to make all the terminal commands boldface and able to be directly copied via Command C and pasted via Command V, copied from this document and then directly into the terminal. So please keep that in mind. Boldface means it's probably going to go into a terminal. Know that this is a static document. It's possible the commands could vary slightly as version numbers change. Try to avoid that, but right now it's not written such that it's completely universal, future-proofed, if you will. And furthermore, the prompts, any prompts that you see on my screen or in this text, are going to be one moment. Sorry about that. All the commands on this document, everything's going to be unique to some things will be unique to your setup in terms of what you'll actually see on the screen. Just like, and I'll try to point out an example of that as we go along. And then the final comment is that the new Apple Silicon chipset versus the Intel chipset, there may be some differences in the setup between the two, and that's still actively getting worked out. So if you have the newer Apple Silicon CPU and have problems, please contact us, and there'll be some support links at the end of this presentation. And we'll hopefully get it set up. All right. So let's get started. We're gonna first get open MP3 enabled G++ compiler using Homebrew. So the first step actually is to get Homebrew. So the make a long story short, macOS doesn't ship with an OpenMP enabled compiler. It ships with Clang, but we need something different. So the way that we're going to get that is by using Homebrew, which is a package manager for macOS. So following this link, it opens up Homebrew, the Homebrew website. This will copy the link to install it to your buffer, and then you can go anywhere. Assuming you have a terminal open, which in order to open a terminal, if you look for this, and that'll open up terminal. So with an active terminal session, you copy and paste. Now, once it's copied, you paste it in and hit return, and it will execute. In my case, I have Homebrew. I'm not going to actually run that command as part of the demo today. That's what I just did. And then basically you'll hit return until it completes. And that's what's specified here. It takes a few minutes, and depending on how quickly you can get things downloaded in your computer. When the installation is finished, you can see where it got installed and kind of otherwise confirm its installation by running the command which brew. I'll run that. And then here it is in the local bin. And that's expected behavior for my computer, which is the Intel chipset. Whereas with a Mac M1 or M2, you might get a slightly different return. So now, assuming that you have the basic Homebrew package manager, you can use that to install GCC. So again, we can copy from the PDF, highlight, Command C, Command V, enter your open prompt. And if you hit enter, which I'm not going to do, I have GCC, it will get all the dependencies for GCC. And that could again take a few minutes. Once it's completed, you can confirm that you have GCC, the Homebrew version, by running the which command. In my case, I actually have GCC 10, not 11. So 11 returns empty, nothing. And if I put in 10, I get the location of my GCC compiler returned. All right. Then I think this is the final thing that we do before we get everything, I guess, the final preparation step. There is one thing that you need to do to your shell environment, and that's create a variable. In this case, it's called PhysiCell CPP, and set that variable equal to this string. You can do that by copying and pasting. Assuming I can grab it. Selecting, copying, and pasting this command into the terminal, which you'll be an expert at by the end of this install guide. And that being said, what that will actually do is that it'll create a variable in memory in your terminal session, and once this terminal session ends, that variable will go away. So what you really want to do is you want to make it so that every time a terminal session opens, that this variable gets created and set to this value. So then actually what we'll do next is the install guide goes through how to do that. So first thing you need to do right now, we're because of changes with Apple, Apple ships with older Apple computers shipped with Bash as the language for the shell, and new computers are shipping with Z shell as the default. So, and we're supporting both in this tutorial. So if you have a newer computer and you didn't change it to Bash, it's likely that you have Z shell. But first thing you want to do is find out which shell you're running. So if you run, get this to select, echo. Echo is a command that says print to screen, and then you're asking it to print the variable shell, I believe. So then I'm running bash. So then I would follow the bash commands. Otherwise, you might find out that you're running Z shell, and then you run the Z shell commands. Regardless, whichever one you have, what these two commands do is it creates a configuration file. So if you don't already have one, then that will be created. Otherwise, it won't do anything with the file. So in my case, I would run touch. First, you would navigate to your home directory. That's cd ~. Then you would run either touch bash or touch Z shell environment from the terminal. And then from that, once you have that, you can use the echo export commands to alter that file. And then the next time you open a terminal, your config file will run and set your PhysiCell CPP variable to the correct value. So that's what these commands do. So since I'm using bash, I'll demo it with this. I'll select this command to alter my bash profile. And then I would hit enter, and you wouldn't see, it would just return to the prompt, I believe. And then you'd be set the next time you open a shell or a terminal, next terminal you open. If you already had one running, you'd have to actually close it and restart it. I'll show an example of that later. All right. But in my case, I'm not gonna run that because I'm using GCC 10. So, and here's how you can verify that you've gotten the correct thing. When you open a new terminal shell, which will force your config file to run, you should see that this variable is already set. You can test that. In my case, it returns 10 instead of 11. Okay, I was right. So now we're all set. We have Homebrew, which allowed us to get the correct OpenMP enabled compiler, and we've set an environment variable so that the makefile that we're about to use will know which compiler it should use. So next we're going to test building a default model, and it's called heterogeneity. So to do that, so basically we need to get our source code. And so we need to get PhysiCell. So that's what this slide is about, is getting PhysiCell. To help us get the latest version of PhysiCell, we have a new file we've written just as part of this tutorial called getPhysiCell.py. So using your browser, which this is a live link. Let's go. This is Python code that we hope will run in any and all versions of Python. And so what you need to do is take this code, take this web page. If you hit save as, should allow you to. When in Chrome it didn't do this, but well, I'm not quite sure what's going on with this. So well, yeah, so that seemed to kind of lock up. So what I'm going to do is I'm going to go to Chrome. Now I have my Python code. I'm going to save the page as, and this is correct. The correct name. And yes, we can replace it. Okay, now I've got something to help me get the latest PhysiCell release, and that's what we'll you need next. If you want to look at additional releases, you can follow this link, and it'll give you all the most recent information about it. But in order to get this Python file, will find the latest release and download it as a zip file. So now I'm ready to actually get the code, the C++ source code, and unzip PhysiCell. So that's what I'm going to follow next. All right. Now I'm going to go ahead and use this one. This is already in downloads. So this is the file that we just got from GitHub. Now I have downloaded, it tells me that I've downloaded version 1.10.3 as this file name. Great. Funnily enough, that's what we have in our tutorial. So I'll move. You can do this as you wish. Our instructions include moving it to the home directory. So now I am going to have to move to the home directory, my prompt to the home directory. That's what this is. CD tilde will move you to home. This command unzips the zip file. No report there, but we'll know in a second if it worked, if it allows us to switch into this directory. Great. So now this is a listing of the directories and some of the files in the PhysiCell source code. And we just downloaded and unzipped, making it ready for use. So the first thing, so in this section, all we're doing is testing to make sure that we have the compiler working. I'm going to use this enhanced make command with the flag -J2 to get it to run on 2 cores because I want it to go a little bit faster. So your output might be slightly different. For example, you may be using GCC 11. And here's an example of where the prompts will look a little bit different. You know, this is my computer, so it has me as a user, for example. Well, that's all right, and then that's the end of the slide. So we know what we're looking for. We're looking once we see this in the terminal, and then return to the prompt, we're done. There we go. So we've got the executable, and we are returned to the prompt. I'm going to go ahead and clear this output to make it a little bit easier to read later. The next set of commands. All right, now we need to make some. Now we can run our executable. Great. I'm going to hit Control C to stop the simulation. The simulation would run for a long time if I didn't do that. And what we see here is some typical output from PhysiCell, where it tells us some stuff about the config file and stuff about the microenvironment. And this will all be covered in the tutorial. And then some initial output of the actual simulation. So this is all expected and documented in the PDF. And then furthermore, we can confirm that we did in fact get that we got more than just terminal output or screen output, that we got file output. So ls output will tell us will list out what's the file names that are in the directory output. Clear, stop the screen. Great, we have several files and several different kinds of files, sets of files for each time point that was saved. Perfect. PhysiCell seems to be working on my computer, which is good. Now, the other thing we can do to verify this even more fully is we can go to in this case, I'm going to use the graphical user interface to navigate the files. And you know, of course, you can do that. I'm showing you the command line ways of doing it, but please, you should do whatever works best for you. And I find that the command line and the and using this graphical file explorer work pretty well for me. I do both. All right, so here's an image output that will give us some immediate feedback on how the simulation went versus looking at either a binary or a text file. And so this was visualized here in Chrome. So in a browser, we have a circle, approximate circle, multiple colors of cells, including some especially red ones. Now let's check that against our example. Yeah, so this fits. And so you can always do that as a simulation is running. Just go to Explorer and look at the files. I think it's probably a good idea to make sure if you have any doubts about whether or not you've run things correctly. Great. All right, so with that completes the minimal setup. And then now let's see what we can do about Python and the other some of the other things that are really helpful. As already mentioned, I'll just say briefly, it's a requirement for certain aspects of PhysiCell. You can compile and run a PhysiCell without Python, but it's really helpful to, there are a lot of helpful scripts written in Python to either get you additional functionality, to get you visualization and data analysis, to run PhysiCell and Jupyter notebooks, and then for additional and other aspects of analysis or optimization. So note that your Mac may have Python 2 installed instead of Python 3, so you can verify what it has. All that being said, even if it has Python 3, it may or may not have everything that we need for all those nice goodies that I talked about before, the additional analysis as an example that you can get. So we're going to go with more than just what the Mac OS comes with. In order to get that, we recommend using Anaconda. It's a Python distribution that comes bundled with all kinds of stuff, like NumPy, for example. To get, you can either, there's two flavors or two options. To do this, you can either use a GUI to do this or a command line executable. First, we'll talk about the command line installer, then we'll talk about the GUI. Actually, the very first thing I'm going to do is go to this download page. So here it is. We want the Mac system. And in particular, right now, we're still recommending that everybody install the non-M1 version. So whichever flavor of installation you want, pick the one that isn't for M1. I'm not going to download any of these right now, but instead I'll just go over the user guide, but you have a choice. Okay, so now assuming you did download the command line installer from the download from wherever you have it, assuming it's in downloads, you would copy and paste this line into your terminal, and then basically hit enter until it's done. Enter. You can have some options in terms of where you install it. And if you enter, that's just fine. And it'll take a little bit of time, just like everything else that we've discussed. There might be a lot of downloads. There's going to be a lot of processing. Note that if you get this warning, you can just disregard it for now. And then finally hit enter, and you'll in essence be done. If you let Anaconda change your initialization, your config file, in order for that effect to take place, in order for that to come into effect, you'll have to close and reload the terminal, is what this is saying. So in order to sort of get a base Python environment, what we're saying is the base Python environment you just installed won't load until you restart your shell. And the simple way to do that is to close the current terminal session and restart it, or open a new window after you've completed the Anaconda 3 installation. And there's a note if you don't want it to automatically start with the base environment. And then to verify which Python, to verify that you have the correct Python, you would run which Python, and it should point to something similar to this. where it says Anaconda 3 -ben -python. There we go. So I have something similar here as well. My username, Anaconda 3 ben python. And then I think a real, important verification would be to just run Python, and it'll tell you what it's running. In my case, I'm running a little bit behind. I'm in 3.6, but with Anaconda. Okay. Now the graphical user, the graphical client accomplishes exactly the same thing. It's just instead of maybe hinting, you don't enter quite as many times. You see the options come in front of you, and it waits until you're ready, and you interact with it. So following this along, first, you have to verify the security settings. Then at some point, you'll get an option to change the installation location, and you'll want to click and install it only for you. So install only for you. And 3 and 4, this is verifying that. So continue, and then you'll have once you've confirmed all the installation, then you'll be back to being ready to install. So in the installation type, make sure you click on, when it comes to installation type, make sure you click on change install location, and actually you want it to do install for me only. And then you can go back to the regular prompts. It'll take a while. And then finally, you get the option to install PyCharm integrated development environment, which is fine. And you can choose whether or not you want to install that right now or not. You can always install Python or PyCharm or something else later. PyCharm does allow, you can get the professional version for free if you're associated with a .edu, maybe also a .org. I'm not really sure. I'm not sure on that one. Either way, you're going to verify it, which Python, or run Python and confirm that it's running Anaconda and Python 3 something. Great. Now we can get an intracellular model going, which is a test of our whole chain so far. So navigating back to where we've installed PhysiCell, where we have our PhysiCell source code, I'll run this command, make reset, and that will make it as if we have a naive, just downloaded version of PhysiCell. If you run the command make list projects, you'll get a listing of all of our sample projects. And in particular, in this case, we're going to want make ODE sample. I'll return to the slides in just a second. Oh, I managed to make it there twice. I'll have to fix that. So anyway, we're going to want this one, ODE energy sample, because it requires it's something that requires GCC and Python 3 to run. So this will verify your installation. So I did make ODE energy sample, and that sets up my make file to make that sample project. Next I type make, and it will run. It's downloading a fairly large file, so that this could take a little bit. It depends on how quick, the amount of time that it takes will depend on how long how fast your internet connection is. I'm gonna have to pause and fix that. I know what's going on there. One moment. All right. Now that error should be fixed. Downloading the file again. And I'm compressing correctly. Now it's running through the entire make. This first part was to get great. That was much faster than I was expecting. Great. So now we have the libroadrunner models. That's what it was downloading, and one of the things that requires Python 3, the script that runs that and makes that. And then it just already made, it looks like it probably already reused the already compiled binaries. And now we can run the executable. But we will get an error. It's to be expected. And so the fix is on the next page. And again, it has to do with an environment variable. So I can create this variable and set it equal to this path. And then to avoid this run, yeah. So let's do that. Now I'm going to, I hit the up, it would be the up key. You can go, you can search, you go one by one up in your command line history. So now it's running. All right, I'm gonna kill that simulation, but I got the expected output. So as before, if you want to put this environment variable in your config file, it's the same kind of thing as we did for the PhysiCell CPP variable. And you won't have that problem again. I'm going to go ahead and do that. Now, the next time I open a terminal window, it won't happen again. Yay, all right. Really, if you made it this far, you're halfway there. Now for ImageMagick. ImageMagick is a free, powerful image conversion, composition, and editing tool. We'll use the package manager homebrew again to get ImageMagick. The command for brewing, installing ImageMagick is brew install ImageMagick. I'm not going to run it. As I already have it, but it's the same as we've been doing this whole time. Copy, select, copy, paste, and it will, when it's completed, when you run this command, which convert is a program or something that ImageMagick installs, it will return with the location of convert. And that's a way to verify your installation. We have additional information available in the GitHub repository for PhysiCell. That information is shows you how to use ImageMagick. I'm not going to go through all these right now, but using if you were to run let a simulation run to completion, like say heterogeneity, or at least run further than I let it run, you can use these commands to make an animated GIF out of the image output, the SVG output. And just to make it clear, it's the same format, copy or select, copy, paste, select, copy, paste, select, copy, paste. All right, then the PhysiCell model builder. This is especially important for the hackathon and is a real continuing great innovation for the community. The model builder is a GUI that lets you create and edit XML, an XML configuration file. And so the XML is a language that we use to specify simulation settings in PhysiCell. So with using it, with the power of that, using that, you can get almost everything that you would need to define a full PhysiCell model in just XML. And the model builder allows you to do that without interacting with the XML, which can be difficult to read. So you want to get the latest release. In this case, we don't. This time we don't have a fancy Python script to do that. So if you follow that link, it'll take you to the repository for the model builder. I'm just going to download it directly. In my case, it's going to go into downloads. So here are my commands to unload, to unzip it. Let's see, where am I? You just can change directories in the downloads. Well, That's because depending on how I download it, I'll get it'll automatically unzip. Anyway, sorry for the clutter right here, but it downloaded a zip file into my downloads and automatically unzipped it. So then this is what I have. So I'll just switch directly into that directory. Great. Which is probably the next command. Looks like we've already updated to 2.6. I might be able to edit these, but note that these, what's in here right now, it depends on you having 2.5.0 as the name of the file and as the name of the model builder, but it's actually 2.6.0 is the latest. Regardless, once you have it downloaded, and keeping in mind that you could unzip directly through the Apple graphical user interface. But we've got our Python command, and then this will pop up the GUI. Great. Now we have the GUI. This output matches output on the next page. Please note that the user guide for the model builder is still being written, and this tool is being actively developed, so your feedback on it would be very valuable. Great, and now we're getting to the last part required for the hackathon. So just a brief bit on what Capacity is and SBML and SBML editors. So Capacity is a simulator, and SBML editor, it simulates multiple categories of mathematical models, in particular ordinary and stochastic differential equations, among other things. And it provides a graphical user interface, or GUI, for editing systems biology markup language, or SBML. So that's a way to specify a systems biology model that is sort of relatively universal. Many folks use this standard. And it's in particular often used for intracellular models, and I think you'll find if you're going through the hackathon, or if you see other projects in PhysiCell, there are multiple intracellular modeling groups and partners of PhysiCell that use SBML. So it's worth noting that, of course, there's multiple SBML editors out there. Capacity is just one of them. It's the one that we happen to be using for the hackathon. So to get it, you navigate to Capacity's download page. And yes, that's correct. I'm running macOS. And this looks like this is the correct one for me. If you were running, I'm not running Monterey. If you were, there's a couple special ones for you. So download the one that's appropriate for you, for your system. And then you can follow their instructions. Their instructions are great. It's worth noting that once you've downloaded it and tried to run it, that you may be challenged by Apple security. If you haven't seen this before, I'll just run over it really quickly. When you download this file and go to actually open it, you may get prompted with a security warning and or it may not run. So what you need to do to navigate around that is pretty much illustrated right here, but I can show you. You open up system preferences, navigate to security and privacy. And then if I had an issue, I would see something similar to right here. I would click confident anyway. So here I see clearly that it's the package that I just downloaded, and I'd click open anyway and allow the installer to run. And it's fine to accept the defaults. And then the final two items before we get into the support and acknowledgements are that oftentimes people want to use a code editor and a note about version control in GitHub. So when you get to the point of editing custom C++ code for your model or custom Python for supporting your model, you would probably want a decent code editor. To make a long story short, you'll get as many opinions on this as there are people who do code, and there's also some specialty editors. We already mentioned one. PyCharm is a specialty editor for Python. CLion is by the same company. It's a specialty editor for C++. And then there's also Visual Studio, VS Code, and that's a broad editor that I personally have used for Python and for C++. But start with something, find out what works for you. And then there's version control. It's common to use version control to secure your code. It can be easy to make a mistake and not know where it happened or how it happened. And with version control, you're really protecting a whole big bunch of code by being able to go back through and see where you made those changes and what may have caused the problem. Also, it's really important for being able to share your code with collaborators. So definitely think that it's important I personally think it's important to be using version control. We use Git. I use Git. I think my understanding is it's pretty broad that folks use Git. And then often folks will use GitHub as a way to share the code in addition to having under version control. And if you're attending the hackathon, you'll notice, of course, that our materials for the hackathon are available on GitHub. We also use GitHub for PhysiCell proper, as well as source code. All right, and then finally, there's support. So we encourage you to join and actively use the PhysiCell community Slack channel, and that's universal. If you're watching this in 6 months from now or 6 years, please join the Slack channel. And if you have questions, problems, you can go to troubleshooting. If you have problems with install, there's an install channel. You can also submit tickets on SourceForge, and please follow the group at PhysiCell and at MathCancer. And then in terms of funding, of course, we need to acknowledge our funders and PhysiCell made this hackathon possible, and this all the support that's gotten us as far in this as we are, and then PhysiCell itself in particular. Great. With that, I think I'll sign off, and thanks.